Hello everyone. I hope you all are good. This is Janish Shah, Assistant Professor at LJ College of Engineering and Technology. In our previous lecture, we studied about the first part of data structure with our first introduction introductory chapter of data structure, where we know that what do you mean by data structure, how many types of data structures are there, and each and every data structure in a brief introduction. So, in today's lecture, we studied about the analysis of algorithm. So, let's begin. Here, today, the outlines of the lecture is algorithm, abstract data type, performance analysis and measurement, space complexity, time complexity, asymptotic notations. So, and examples. Now, begin with the definition of algorithm. I hope in your CPU subject you already know about the algorithm. So keep thinking in your mind that what do you mean by the algorithm? As far as we're concerned, the algorithm is a step by step or set of instructions which are executing in step by step. So the algorithm is a finite set of instructions that it followed and accomplished a particular task. Suppose I want to tell you that go down from your classroom and bring a key of your Activa. Then what you are doing? First, go straight, take left, go down to the seventh floors, then go into the parking, take the key of your Activa, and get back to the follow the same steps to come again into the classroom. So these steps are the instructions. Okay, so when you are following such type of finite set of instructions, that thing is known as algorithm. Here, each and every algorithm has some finite criteria. The first one is the input. An algorithm never work without the input. If you want to sum of two numbers, that two numbers are known as input. If I do sum 20 comma 30, then 20 and 30 are known as input. There are more quantities than externally supplied. That thing is known as inputs. Output, the result which is going to be generated from it, that is known as output. Then definiteness. Each instruction is clear and unambiguous. Your instructions should not be ambiguous. Make it clear and very specific towards your steps. Next one is finiteness. If we trace out the instructions of an algorithm, then for all cases, the algorithm terminate after a finite number of steps. It should not go in infinite loop. Okay, if I run a for loop for I is equal to 0, I less than n, I plus plus, and if I never define n and computer take it from the garbage value or take it as an infinite number, then loop is continuously executing for n number of times. So the loop or anything or an algorithm, each and every algorithm, if we are going to trace it, then it should be terminated at a specific amount of time. Now, effectiveness. Every instruction must be basic enough to carry it out in principle by person using only pencil or paper. It is not enough that each operation be definite, but also be feasible. If you told me we have so many steps, if I told you to go down, then you have two options, three options. First one is to choose stairs. Okay, it is feasible way. Second one is go down from the lift. It's another feasible way. And the third step is jump out from the window. Okay, so here, which one is effective? Jump out from the window? No, not at all, because it is not a feasible way to go down. The same thing will be happen with algorithm. You should have the feasible solutions with you. Moving forward to the next topic, abstract data type. Abstract. Can anyone tell me the what do you mean by the abstract? Okay, let's start with the word abstract. What do you mean by the abstract? Have you ever think about it? Abstract, it means a brief overview. you should not go in a detail, but you have simply overview. That thing is known as abstract. If any function is going, if I told you there is one function which named is integer sum integer a comma integer b. I'm repeating it, integer sum integer a comma integer b. At the time what happens, that you can understand with the name of function that this function may be used for sum or addition of two numbers a and b. But how it will be added or how the function will be executed inside or function definition, do you know about it? No. You can assume with the name of that function that it can be used for the addition of two numbers, but how? No, we don't know. So anything we can get it from its name, or we get the brief overview of a function, then it means as abstract. You don't know anything, its implementation. Okay, how it will be done is not known, but what is going to be done is known. That thing is known as abstract. So moving forward, abstract data type is the data type whose internal representation is hidden from the client. Okay, abstract data type is a type for objects whose behavior is defined by a set of values and set of operations. There are so many values and operations are there on a particular data type, but you don't know about in detail. First, implementation independent view like stack, linked list, array, each and everything. So what do you want to say? We cannot understand about the abstract. Make it very simple. If we take a stack, we usually told that push and pop operation. In our first lecture, I told you that in stack, whatever going to be inserted inside the stack, which is known as push, and if you're pulling some out from the stack, which is known as pop. Okay, so two operations are there, one is push, another one is a pop. So this push and pop, from these two words you can understand that something going to be inserted in the stack and something bringing it out from it. But how the process will be done, you do know? No, because it's an abstract. At the time, this time, that both terms are abstract for you. Okay, so implementation independent view. Implement is on another end. Okay, but the function definition is on another end. So declaration and definition both are on a different side. Now the next topic is performance analysis and measurement. Now tell me, if I took this mobile phone and I want to measure its performance, what I do? I'm going to test it, right? I'm going to test this phone. If I want to test its durability, then what I did, I just throw it from the down. Fifth floor, second floor, first floor, at the distance of 10 meter, at the distance of 50 meter. Okay, such like this, I can measure the analysis or performance analysis of this phone. Another thing, I'm not talking about the durability. If I'm talking about the performance, actual performance of the phone, then what I'm going to do, I'm installing so many applications inside it, and unlock the phone, lock the phone, click on the Google, Play Store, YouTube, each and every elements. I'm trying to store more memory inside the phone, and then I want to use it. So what happened at this time? Your phone maybe sometime hang. Okay, we all know that in internet session or in Zoom meeting, our phone little bit hang out due to internet connections. The Zoom, your face is not visible to your instructor during the exam. So these things maybe happen. This is the performance analysis and measurement. And the big is whenever your result will come out on the GTU portal, so many students try to visit the website. At that time also the GTU website performance can be measured, that how many number of students can access the website at the same time. So this performance analysis and measurement is very important, and we are using it in our day-to-day life. It's not a new topic for you. Okay, but it can be a new topic, that how to measure the performance. Fine. So here, to measure the performance, that we are considering such following thing. The first one is the algorithm provide exact solution? If you have problem and you don't have any solution, then what are you going to do? Is it easy to understand? Is it easy to implement? If I have a solution for you, but is it not easy to implement, then algorithm is not going to be work feasibly. how much memory space is required to solve the problem and how much time it takes to solve the problem. If you people know that before 4G, we have 2G, and whenever I click on the google.com, your phone is loading. Browser continuously loading. But now what happened with the help of 4G internet facility, when you are just scroll down your Facebook account, okay, then you can easily watch the videos. You are just waiting for the 3 second or 4 second maximum to watch a particular video because you are used to with that. Okay, the time matters a lot in algorithm, in process, in program. The time matters a lot. The less time you consume, the system is very best for you. Next, so performance analysis measurement can be categorized such like this way. The first one is space complexity, second one is a time complexity. Basically we measure the performance in a two different ways, so in according to the space and according to the time. According to the space, that means how much memory occupied by an algorithm. Okay, fine. The second one is this time complexity, that how much type of time taken by an algorithm for the execution. Fine. Okay, so space complexity is another categorized in two ways: fixed size space and variable size. If your variables are fixed like integer a, integer b, then it's fine, the space is fixed. It occupies only, if I'm declaring two variables, it occupies 4 bytes if they are integer. But if I am declaring a pointer variable or a dynamic memory allocation, if I use, then it depends on the runtime. If user say that I want the 5 size array, it will generate the 5 size. If user say 10 size array, it will generate a 10 size. That means at the compilation time, we cannot conclude what the space occupied, what will be the space occupied by an algorithm. So that thing is known as variable size. Fine. Also in a recursion, if user enters number 5, if I want to find the factorial number 5, then it will generate 5 times stack. Okay. Then if I want to find a factorial of 2 now, then function will be executed 2 times. So according to that, variable size can be different. So size complexity, sorry, space complexity, it means that how much amount of time space occupied by an algorithm. Okay, now moving forward, the next topic is a time complexity. Time complexity, it has three cases: base case, average case, worst case. We will see it about later in this lecture, but the base case, average case, and worst case, I want to give a simple example of the time complexity. If I have an array of 10 numbers, 1 2 3 4 5 6 7 8 9 10, okay, I want to search number 1. How many comparisons are there? A of 0 and key is 1. A of 0 is equal to 1. Okay, yes, that means how many comparisons you did to find out the one? Only one comparison. Okay, but if I want to find out the 10, then 1 1 10 1 wrong, 10 2 wrong, 10 3 wrong. At the last index you will find out the 10 variable. So how many comparisons you did to find out the 10? 10 comparisons. If I want to search out the 5 comparisons. Fine. Is it easy to clear? So during searching algorithm, if my input or the key is 1, it is a base case because I got the output only in one comparison. Is if it is 5, I got the output in 5 comparisons, it can be a average case. And if I want to search out 10, then it can be a worst case. So such like that, we can divide it time complexity. So here is space complexity. See, the space complexity is the amount of space in memory occupied by an algorithm to execute and produce the result. Space complexity can be explained as A plus SP of I. A is a fixed part of an algorithm. SP is a variable part of an algorithm. Okay. Now, if taking an example, integer C is equal to A plus B plus 20. So 20 is a constant, 20 is a constant. Okay. So the space is occupied by the 20 constant, that means 1 plus 3 into 2. How many variables are there? 3 variables, A, B, and C. Each and every variables of type integer. That's why they occupy the 2 bytes in the memory. 3 into 2 is equal to 6 plus 1, total 7 bytes occupied by this instructions. Okay. Now, next one, another example of space complexity. Calculate the space complexity for below function. Function is test z is equal to a plus b plus c, return z. Please concentrate over here. Here, how many variables are there? Sir, total 4 variables are there. A, B, C, and Z. So how many space will be occupied? 4 multiplied by 2, 8. But listen, this function returns something, that is Z. Okay, that means Z is also a variable as a return type. So it will be also considered as that. So 4 into 2, that means 8 plus another 2 of return Z. Fine. So total 10 bytes will be occupied by this space complexity. Another example, this sum integer a array, integer n, this function will be executed. So how many variables are there? A of n. A of n size is n. Okay. So n 4 into 2 is equal to 8. First of all, the number of variables are n, x, I, and return x. Okay. That means 4 x and I and return x. 4 into 2, 8. Okay, fine. The next one is the array size is n. Array is a type of integer, so 2 into n, 2n plus 8. So how many bytes will be occupied? 2n plus 8. Okay, now next is time complexity. Amount of time taken by an algorithm is known as time complexity. Time complexity is mostly expressed using the big O notation. What do you mean by the big O notation? Students, big O notation represents the worst time complexity. So why will take always the worst, not best? Can you tell me that Tupperware company always told us if you throw our products from the 10th floor or 5th floor, they will still not broken out because they know that maximum capacity. What is the maximum capacity? If you people can learn and watch the online videos till more than 4 hours and you still get it, that means you can learn for 4 hours continuously. But after 4 hours, you are not able to understand properly. That means what is the worst complexity is 4 hours. Can you understand me? Each and everything can be explained as a worst time complexity, always in a bad case. So, objective of the time complexity analysis to determine the feasibility of an algorithm, to compare different algorithm before implementation, analysis based on the amount of work done by an algorithm, complexity express the relationship of size of the input at the runtime of the algorithm. To simplify the analysis, we sometimes ignore the work and take constant amount of time independent of the problem input size. Now, the time complexity, the things we need to consider during the time complexity is arithmetic operations performed like a plus b, 3 minus 4. Any comparison occurred in your algorithm like while 5 less than 10, while a less than 10, if a greater than 10, if a greater than b, and b greater than c, such type of conditions. Also number of array element access. You, you all need to focus on this all four things. Example, taking an example like x integer a for I is equal to 0, I less than I plus plus, a is equal to a plus I. Now listen it carefully that integer a is a statement. This function we need to calculate the time complexity. For here we are taking one as for the one instruction, one time for the one instruction. Okay, so integer a executed at only one time, that means one. In I is equal to 0 is the initialization step of for loop. It will be executed at only one time. That means 1. Okay, now I less than n. I less than n. How many times it will be executed? If n is equal to 3. If n is equal to 3, then I is equal to 0. I is equal to 1. I is equal to 0. For I is equal to 0. 0 less than 3. 1 less than 3, 2 less than 3. Fine. 3 times executed for 0, 1 and 2. But again I plus plus, it becomes 3. 3 less than 3 condition will be false. Condition will be false. That means your statement will be executed n plus 1 times. Okay. 3 times, n times for the true conditions and plus 1 time for the false condition. That's why I less than n will be executed for n plus 1 times, I plus plus for n time. Obviously, it's n time. A is equal to A plus I for the n time. Under the for loop, the statement will be executed n times. If I want to ask you to print India for 5 times, what will you do? I is equal to 0, I less than 5, I plus plus. At that time, India will be printed for 5 times. Okay, now total is equal to, now calculate all these things. 3n plus 3, 3n plus 3, such like this, we can conclude it that the function of time complexity is 3n plus 3. Fine. Addition of this is known as a function f of n, 3n plus 3. Now, how will calculate the time complexity in a worst case, base case, average case? Okay. And what are the looping calculation about, or what will be the time complexity for the loop? These all things we will see in our next lecture. Till that, if you have any query in the space complexity, a little bit query in the introduction of time complexity, then feel free to ask. Thank you so much.